Hi, welcome back. We are looking at solving equations in these videos. And solving equations is the same thing as making true statements. What it means to solve an equation is making true statements. And I kind of think of that as the theme of Algebra 2. We are making true statements and looking at what we need to do in different situations to make a true statement. So a solution is a true statement for a problem. In order to make true statements in solving equations, we need to use the properties that we looked at in our last video. So as a quick refresher as to what those properties are, we have reflexive, symmetric, transitive, substitution, addition and subtraction, multiplication, and division. In addition to those properties of equality, we have the properties of real numbers, like the multiplicative inverse that we are going to use in these to solve equations. So when we're looking at solving equations, we want to pick the property that will allow us to isolate the variable. So when we have an equation like x minus 14.29 is equal to 25. Now the variable x can take on any value. It is possible for this variable to take on any value. That's what a variable is. It represents any possible value. Now, x can take on any value, but it won't necessarily make a true statement. When we're asked to solve an equation, we're asked to find the value of the variable that makes this statement true, okay? So we are making only true statements. We can make a lot of false statements, but there is only going to be one value of x in this problem that will make a true statement. Later in the year, we might be finding, or even in our next section, we might be finding more than one value of x that will make a statement true. But for right now, we just want to make a true statement. So we're going to try to find equivalent statements that help get the variable by itself for us to solve this. So I want to get rid of this negative 14.29. So I am going to add the additive inverse. But my addition property of equality says that if I add it to one side of an equation, I have to add it to the other side of an equation. This is an equation, there's an equal sign. So I am allowed to add something, but I have to add it to both sides. So this will now give me x plus 0, so I'm not going to write that because it's just 0, is equal to 14.29 plus 25, which becomes 39.29. So what this is saying is that if I plug in a value of 39.29 to this equation up here, I should get a true statement. And I can check that out. So I'm going to check my answer. 39.29, so I'm plugging in, I am substituting in 39.29 for my variable x, minus 14.29 is equal to 25. When I check a problem, when I check an answer, it's really important that we don't mix between the two sides because we might make a mistake or invalidate our solution. So we just want to simplify the left and simplify the right. 39.29 minus 14.29 is 25. So I get 25 is equal to 25. That is a true statement. So when I plug in x equals 39.29, I'm making a true statement. So that is the solution to this problem. In our next question, I have 2/3 y is equal to negative 18. I'm going to multiply both sides of this equation by the multiplicative inverse, because if I want to get rid of 2/3, I should multiply by 3/2. When I multiply one side by something because of the multiplication property of equality, I have to multiply the other side. So when I multiply 2/3 y by 3/2, my 3's cancel and my 2's cancel, leaving me with 1 times y. Negative 18 times 3/2. I'm going to do the multiplication first here. Or the division, so 18 times 2 leaves me with 9. Negative 9 times 3 is negative 27. I am going to check this answer. So I'm going to plug y equals negative 27 into my original equation. So I have 2/3 times negative 27 is equal to negative 18. 2/3 times negative 27. Well, so that's 2 times negative 27 divided by 3. 27 divided by 3 is 9. 2 times negative 9 is negative 18. Negative 18 is equal to negative 18. So if y is equal to negative 27, that makes a true statement. So these are one-step problems. In our next video, we'll look at a multi-step problem to look at how we can extend this.